Hello everybody, today we will be going over a volumes problem at the IB Math Studies level. So we have that Fresh Wave brand tuna is sold in cans, which are these cans here. They're the shape of a cuboid with length blah, width, height, blah blah blah. Okay, then we have that the Happy Fin brand tuna is sold in cans that are cylindrical, which is this one right here, and they give us diameter and height. Beautiful. We need to find the volume in centimeters cubed of the can of the Fresh Wave tuna and the Happy Fin tuna. And so first things first, nobody knows these formulas by memory. So what you're gonna do is you're gonna open up your trusty rusty formula booklet and you're gonna find the volume of a cuboid and a volume of a cylinder and work from there. Having that in mind, we look at the formula and let's start off with the cuboid, right? For the cuboid, we need length times width times height. And so we look at the problem and they give us the length right here. So I'm just gonna plug in 8 for now. They give it the width right here, which is 5. And they give us the height right here, which is 3.5. Beautiful. We can go ahead, plug and chug, and end up finding the volume of this cuboid in particular immediately. And so if we put this into our calculator, we're going to have 8 times 5 times 3.5, and this gives us 140. And so, very importantly, we need to remember the units, which would be centimeters cubed. It's cubed because it's volume. It would be squared if it's area, and it's to the power of 1 or without anything really when we're talking about distances. Okay? And so that is for the volume of the cuboid, and for the volume of the cylinder, we know the value of pi, right? In fact, we can plug it in our calculator. It is it is above the division sign. Okay, second blue. We need the radius, and so we look at the information that they give us, and they give us the diameter, okay, and then they give us the height. And so for now, I'm just going to leave the r here, and I'm going to put the height over here. So right now, we're in a position where we need the radius with the information that they gave us. Now, what is the diameter? The diameter of a circle is what cuts through all of it, okay? The radius, on the other hand, is from the middle to a side, okay? Effectively, a diameter, just visually speaking, is 2 radii, or radius. You know what I mean, okay? This whole diameter here is really 2 blue lines, and each of the blue lines is a single radius, okay? And so, if they give us the diameter, that is 7, and using this function here, we can see that 7 equals 2r, and r has to be 3.5. So that is just a little bit of information of how diameter gives you radius and how radius also gives you diameter. And so plugging in 3.5 over here, remembering that it's squared, and times 4, and putting this all into the calculator, we're going to end up with the following. We end up with 153.9380. And of course, do not forget the units. So that is for parts A. For part B, it gets a little bit more complicated. But even though this part is more complicated, look at the mark scheme, okay? This first part is worth 4 points, and all you needed to know is to find the function in the formula booklet and to put your units, okay? So this problem has easy points, but you need to trust the process and remember the units, okay? And also know the thing of the diameter. For the next part, they give us that the price of tuna per centimeter cubed is the same for each brand, okay? And that a can of fresh wave tuna costs 90 cents. Therefore, we're going to calculate the price in cents of the can of a Happy Fin tuna. Essentially, there's a relationship between, how do we say this? 1 centimeter cubed is an X amount of money, right? The other thing we know is that 140 centimeters cubed is 90 cents, right? I'm actually going to put cents here instead of dollar sign just to leave it more consistent, but you know what I mean. Here we have a proportion, right? We don't know how much 1 centimeter cubed is worth, But we know that 140 centimeters cubed is 90 cents. And so if we set it up in this manner, we need to get the value of x. We need to get x alone. And what is usually suggested in a scenario like this with a fraction on each side is that you cross multiply. You do 1 times 90 and 140 times x. And so I'm going to end up with 90 on one side, and on the other side I'm going to end up with 140 times x. Okay, and just to leave it super hyper clear, I'm going to put parentheses here. We ended up having 1 times 90 and 140 times x, right? And so the 1 times 90 is just 90. This is just 140x. We get x alone by dividing both sides by 140. And we end up that x is x is just about 0.6428. Okay, I suggest that you put all the numbers in the decimal point just to be consistent. And so, going back to our relationship that was up here, we know that 1 centimeter cubed is worth just about 0.6428 cents, right? And so, if for the can of if for the can of Happy Fin tuna we have 153 centimeters cubed, 0.9380, what we need to do is take that amount, the 153.9380, and multiply it by the 0.6428. Essentially, what we're doing here is my amount of centimeters cubed times the cents I get per centimeter cubed, right? So the cents I get per centimeter cubed is the 0.6428, and the amount of volume that I am dealing with is 153.9380, which is the same number we got for part A up here. Okay, so that is the process that we did to solve this problem. And more importantly, it was setting it up like this that was very, very important. Okay, and so plugging this in to the calculator, we have this guy up here times this guy down here, and we end up with just about 98.96. So the answer would be 98.9601. Okay, so this would be the price in cents of a can of Happy Fin tuna. And just a way to double check your answer, if the can of the fresh wave tuna costs 90 cents and it's about 140 centimeters cubed, if the other one is about 150, it should be a little bit over 90 cents. And effectively, it is. It is just about 8 cents more. Okay? And so that is how you solve this problem. The most important parts are, of course, getting familiar with the formula booklet, knowing the relationship between diameter and radius, and also being able to set up proportions like this, which also has to do with the fact that if they give you a piece of information, you damn know for sure you have to use that piece of information. So get creative with it, but make sure that you use whatever they give you. The IB likes to do it that way. So that is how you solve this problem, and I hope it helped. Peace. Just one final comment. If you look at the answer key for part B, the final answer is 99 instead of 98 point blah blah blah. This is because technically you can't really have like half a cent, and so it is more accurate to just leave your answer as an integer, which is the same as saying just a whole number. Okay? And so that is another small thing you need to know, even though the answer we got was more accurate, and you probably can argue to get full points anyway.